Okay, just forgot to record, but let's just get started here with the Excalibur. The idea is let's try use 2 pointers, and so combine. Yeah, we'll combine the words, and then does it say anything about the word length? Okay, and then words dot length is less than or equal to 300. Words I dot length is between 1 and 20. So there's going to be at most 300 words, and it seems like there's going to be at least one word. Okay, good. So if there's at least one word, then what we can do is of non-space characters only. Okay, so I need to also get rid of any white spaces. So we do join words, and then we do combined dot strip, Python strip. How do I use Python strip? Okay, yeah. Python. Oh. Okay, we'll first clean it up a little bit. So we do words equals to word we do for word and words, and then let's just do clean words. We do clean dot append word dot strip, and then we do combined. We can do combine join clean words. Okay, so this ensures each word, good, and then once we join them, that's exactly what we need. Because, yep, okay, and then now once we do that, we combine it into a single sentence, we point, so we increment the pointer until we see the first white space. And then once we see the first white space, then if it's less than, we counter, so it's fine. And then here we at the end of the white space, and then we count how many characters there are. So if the character count is less than the word count, then what we can do is we can so we have a starting pointer somewhere. We have 2 pointers that increment. We'll have a pointer that increments. So it goes over here. We can do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it thinks, okay, 11 is fine. So then it keeps on incrementing. 12, 13, 14, 15, 16, 17, 18, 19. So I need to have 3 pointers then maybe. And then it realizes, okay, well, example can't exactly fit into it. So then this is an example of text justification. example. So we see the example, the word can't fit into it, so then we just basically, we have to format this is an, like this substring specifically. So far we've only looped through it once. And then now, but then I'd have to break it up, and that's just, like, what's the point of doing that then? If that's the case, I think we should still keep it in an array, and then with the justification, with the word width. So I mean, it's pretty easy to figure out just exactly how many spaces I need to have. It's left justified because it's the final. Oh, okay. Wow, this is actually kind of annoying to deal with. What would be the pattern we have to do? Let's just, for word in cleaned, I guess we can just do start equals 0, n equals to 0, increment is equal to 0. And then we do for I in range len cleaned let's just think of, like, how would it even work in this case? Because here we just loop through the words until we reach the end of this one. And then we need to have white spaces. So the white spaces luckily can be represented by the index itself. So how many regular white spaces there needs to be. So we start off with we'll start off at -1 for the white spaces to make it a bit easier. So we would first increment through the words, so 4, 6, 8, 9, 10, and then what happens is, well, the start is still going to be, the starting index is still going to be here, the ending index is here so far, and then the incrementer, it goes to the next word. it counts the next word, realizes that it's over, which means now we know that this becomes a single line. Justify equals to this. This becomes a single line, and then what we can do is we can because now we have how long it is, so then we know how to allocate, because here it's the length is 3. The length is 3, so it will be 2 minus. It will be 2 minus the index plus 1, because we need to account for the subtraction off by 1, so it will be 3. And because it's so then it will just be the indexes minus by each other, because we need to just figure out how many spaces are in between them. And if the spaces in between them is 2, we can figure out, max width minus the number of characters we have so far. Max width minus the number, max width minus the number of characters, and see if we are over. So we don't even need this part. So I don't think we need a loop. We can just do while increment is less than len clean. We can do this. We can do substring length equals to 0. So then once we get to this part here, we increment this starting index. We go boom, and then we go boom until it reaches the end. And then once everything is done, we append it to the list, and then we set everything over here again. And now the incrementer keeps on going. So then the incrementer goes on to the next line. It goes so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it goes over here, realizes, okay, no, it reaches the second word. The first word is fine. It counts the second word's fine, so then this end pointer points over here, and then the incrementer goes to the third word's fine, so the end pointer goes over here, and then it goes to this word, and then it realizes it doesn't. So then at this point, so if justification plus the number of white spaces is equal to plus the white space is equal to or is greater than the word length. Sorry, if it's greater than the word length, then what we can do is, we can start iterating over this subarray. So example of text, we add them to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 words. Hold up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh no, 14, 15. It's going to be 15 characters. And we know that there's going to be 2 spaces. And then because there are 2 spaces, okay, the problem now then just becomes, okay, I have the idea right, because this will be all of n time, because you're just looping through the words at most twice, but then the white spaces, how do I deal with the addition of the white spaces? If there's 2 white spaces and 1 word, how would I know to, or what's the general way? If there was, let's say, 3 spaces, or so here it's also 2 spaces, but what if it was more than 2 spaces? If it was like 3 spaces and 4 extra leftover characters, how would I know to justify them properly? Like using pigeonhole principle or something. Because I can't be doing a round robin, that will take way too long, so So like if I'm combining the words, what do I know? I know that there's going, because based off the pointers, I know there's going to be 3 words. I know that there's going to be I know there's going to be 13 characters. And I know that there's going to be 16 spaces max. And I also know that there's going to be 2 gaps between words. So using this information, how can I figure out, well, how many characters to put between each gap as I'm iterating? Because I'm gonna obviously be iterating through this. I'm gonna go example, so subword plus equals the example, and then I'm gonna move to the next one. So then once I move to the next word, I know that there's going to be 2 words left. There's still going to be 2 gaps between words so far. And then I know that there's going to be, well, 6 characters, excluding any white spaces, and I know that there's going to be 9 spaces left. Well, at this point in time, how am I going to know how many spaces to put between the gaps though? Unless I can just keep track of the actual gaps in between the words. And now let's see if there's only one word now. plus equals the cleaned index. And then we need to add the white spaces, at least one white space to account for everything. So then let's just go back to the start here. Last index, and now we do index plus equals to if we can do n equals to idx, and then we do idx plus equals to 1. Because here, it's entirely possible that we might just reach the end, and then we just need to, because for the last row, we're guaranteed this is going to be, and then now we do left justify the final values. Because we would have the substring length, and it excludes the left justify final values. Wow, this, and then we can just, like, while idx is less than cleaned, you can just append the final word. Okay, we'll deal with that later, I guess. Oh, so if it's greater than or equal to the max width, so then, yeah, this is the problem. How am I supposed to, how exactly do I do this? So here, we do idx minus star equals to else take the words between the start and the end. Okay, how can we do this then? We do while start is less than or equal, while start is less than or equal to n, because these represent the indexes, we do the string is equal to just empty characters, while start is less than and can't append them quite yet. Because right now the biggest problem is because I can do it by just doing a for loop, but then a for loop, what if I have like 100? What if the max width was like 100 and then I only have 2 gaps? I'd have to keep on looping around the gaps, wouldn't I? So I guess the other question would just be, how could you divide up the counters as evenly as possible? Say I just have 3 positions here. It's like go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. I can do that, but then if it was 11, how am I supposed to know that, let's say, this is going to be 4, 4, and then 3? Okay, I have an idea. So if it was, let's say, 11, we do 11 divided by 3. We take the floor of that, which gives 3. So this is going to be the default gap, and then we're going to have a remainder remainder 2, so we can calculate that with the modulus. So then we can do, so after each step we can just calculate we can add on a space that is this size, that is of size 3, and then we do if remainder is greater than 0, we can tack on an extra value, I think. Yeah, this will work. Okay, cool. Well, start is we can do minus substring 1. This is how many spaces I need to divvy it up between. Minus substring length. So this is how many white spaces I have, and then And then we do, or how many positions, or how many positional white spaces must there be? We can do spaces is equal to idx minus the start, which just represents the number of, well, white spaces. No, I don't even need for, I can just do white spaces divided by this. Does Python division round down? Yes. Okay, good. It will just floor it, which is exactly what we need. This gives the allocation, and then we do remainder is equal to white spaces mod spaces like this. So this would, well, start is less than n. What we can do is we can do s plus equals 2, and then we can do cleaned start, and then we can how do I append on white spaces efficiently? How do you even analyze the complexity for a question like this? Append on a white space, so we can just do for I in range allocation, we do s plus equals to white space, and then after this we do if remainder is greater than 0, we can allocate another white space, and then we do minus equals to 1. And then we need to make sure while start does not equal to end. Then we can do all of this stuff over here. Because if it is equal to, then we shouldn't be appending any extra words at the any extra white spaces at the end. Cool. So I think that should work. And here we just need to do start plus equals to 1 to keep on moving it forward until it reaches the end. Like this. And then once all of that is done, we can do justified. Justified dot append s like this. And then here I also need to restyle the values. We do end is equal to start, because the loop will only break once it goes beyond it, so it will all be at the equal place, and equals the start, so we ensure that everything starts up at the same place again. We do substring length equal, and then yeah, we do substring length equals to 0. We reset that, and yeah, that should be good then. Justify.append. And then once the for loop breaks, we just need to make sure to justify whatever's left. So we do while start is less than or equal to end. Let's justify final values. So we'll do count, which represents the last line count, would equal to substring. We would have already had a substring length, which excludes any white spaces, plus idx minus start. To represent, well, how many words there are. Leftover is equal to max width minus substring plus idx. So this represents just how many. Okay, and then we'll do while start is less than or equal to end. While start is less than or equal to end, s plus equals to cleaned start, and then we do s plus equals to start is equal to end like this, and then if start does not equal to end, then we can do s plus equals to a white space, and then once that's done, we can do for I in range left over, we do s plus equals to this, justify dot append s, and then we can finally return it. Oh my god, this is terrible. What? Memory limit exceeded. Oh no. Exceeded the memory limit. What if I just don't do clean? we just do that. What if I like just don't clean it at all? Time limit exceeded. Okay, well I guess that's not very good then. Time limit exceed. How can I? How can I just see if? Oh, there's a timer up here. I can check how long I. Okay. How can I ensure then that I do end up with enough spaces or enough time? It says to take a greedy approach, so I guess I should just add it on without thinking that much. Um, yeah, I probably don't need to actually clean it. But this one over here would only ever loop through it at most twice. Is it really that slow? This is an example of text justification. You can just do this. We move it forward by a bit. Go up to here. Time limit exceeded. I think it's just because of the for loops over here, like just adding all of the spaces. Like this thing over here. Is there a way I can add the white spaces more efficiently instead of doing it just slowly with a for loop? No, I'm not sure. Let's take a look at the solutions. Round robin, yeah, exactly, just round robin. initialize a result. Well, that's a lot. Okay, whatever.